to handle over the session. Thank you, Ananda. Over to Parthiban to prolong the session. Thanks, Mark. You can proceed on.
Thank you, ma'am.
Thank you, ma'am. Thank you for your support, ma'am. Now,
Okay.
this is the time to introduce our resource person to our distinguished participants. Our resource person received M.Tech in Intelligent Systems from Institute of Information Technology, Uttar Pradesh in the year 2004. He received his PhD from JNTUA, Anandpur, currently working as Head Research and Professor of Information Technology at Bluecrest University, Liberia. He has 19 years of teaching and industrial experience. He has published more than 149 papers in international journals and conferences. He has attended more than 155 workshops, symposiums, and seminars. He has conducted and acted as resource person for more than 85 international or national conferences. He has received Bharat Vidya Ratan, a national award from International Business Council, Delhi, on December 14, 2018. He has received Best IT Teacher of the Year from ITAP and Tutors Pride, Hyderabad. He has received many awards such as Best Mentorship from IBM TGMC Challenge Contest and Microsoft in 2011 and 12. He visited many countries like Malaysia, Thailand, Singapore, and Liberia. Now, I request our almighty resource person and the star of today's session, Dr. Asadi Srinivas, Head Research and Professor of IT, Bluecrest University, Liberia, with the topic Cloud Security Using Big Data.
Thank you, madam, for a nice introduction. My voice is audible, madam?
Audible, sir?
Yes, sir.
Yeah. Thank you for nice introduction. Today we'll see the buzzwords in the industry, cloud security, and as well as big data technologies. How these two trends are leading in the market. So before going to my topic, check if you have internet, what is happening in the internet. I'm going to show you now. Check all of you. Just I am opening internet live statistics. My screen is visible, madam. Hello.
Yes,
Sir,
sir.
visible, sir?
Visible.
Yeah, if you have internet, please type, my dear participants, www.internetlivestats.com. Now see, the number is drastically changing now. How many internet users are connected in the world right now? Total number of websites opened in this second. Email sent today. Please check all of you. Google searches today. And how many tweets in this second? See number. I cannot read such a huge number. How many active users are there? How many videos viewed today on YouTube? See, number is drastically changing. And photos uploaded, and as well as Facebook active users. Please check all of you the number. How many Twitter active users right now? The number is changing drastically. Skype users. So you may get a doubt, sir, where this data is going, how the data is storing, and how many servers are required. You may get doubt. So in order to solve these sort of questions, we are introducing cloud computing here. So if you see how many users are sharing the information, how many users are actively connected to the internet, and where the data is storing, how much servers are, how many servers are required. So in order to solve such type of questions, we are introducing cloud computing concept today. Today's agenda is introduction to cloud, cloud architecture, cloud security, and how cloud security can be managed with help of big data technologies, and what is big data fundamentals, big data architecture, big data challenges, big data security, and a few real-time applications I have executed in this pandemic situation by using big data and cloud technologies. And today's my objectives of this program, international webinar, to define 3 security goals, to define security attacks that threaten security goals, to define security services and how they are related to 3 security goals, to define security mechanisms to provide security services, to introduce few more techniques like cryptography and steganography and few more cryptographic algorithms and implementation security mechanisms. And if you see the current trend, big data and artificial intelligence, machine learning, deep learning, what is a FOSS? FOSS is nothing but free open source software. So the exact meaning and technical meaning of FOSS is nothing but allows users and programmers to edit, modify, and reuse the software source code. That is called the free open source software. Nowadays, we are using various free open source softwares such as Linux, Hadoop, Spark, OpenMRS, Python, Typo3, and Sanatic, Opera, various cloud like FreeBSD, Debian, and these are the HBase, Java, Python, Weka, Hive, various softwares we are using. So why this cloud computing for big data? Cloud computing is nothing but internet-based technology. Without internet, we cannot access any kind of service or application. And how this cloud computing is help to big data? Big data is nothing but it deals with the large amounts of data to store huge volume of data in the servers. The integration of high computing servers at one place is called a data center. Data center is the backbone of cloud computing. And virtualization is also one of the backbone of cloud computing. Virtualization is the ability to perform multiple tasks in a single system with the help of VMware, Hypervisor, Zen, Virtual Iron. These are the popular virtualization technologies. If you are using Ubuntu Linux operating system, the greatness of Ubuntu operating system is it is inbuilt with security mechanism, because with the help of virtualization, they have incorporated VMware software into the cloud environment. So the backbone of cloud computing is a data center and virtualization. I think everybody knows data center. Data center is nothing but integration of high computing servers at one place is called a data center. And without internet, we cannot access any kind of service. The best example for cloud computing is Gmail. Gmail is a best best consumer of cloud computing. Gmail server is located at USA, but remotely I am accessing Gmail account 24/7 without any problem. So Gmail comes under SaaS application service model like software as a service cloud. So big data and cloud computing, a perfect combination, because we are executing huge volume of data applications like Facebook application, weather forecasting application, supermarketing data application, stock market application with help of cloud technologies. Because in order to store huge volume of data, we are using backbone of cloud computing is data center. See, you are a best example. See, you are using Gmail account because they are providing free of cost, but they are selling your data to the other companies, because without money they are asking your details freely. You are giving your details to the Gmail Whenever you are registering a Gmail account, you are providing your name, surname, date of birth, mobile number, email address, hobbies, everything you are giving to the Gmail account. Definitely, they are taking your data and they are applying their own techniques in order to do the opinion mining, sentimental mining, behavioral mining, and they are selling your information to the other companies, and that is called predictive analytics. They are generating revenue. So big data and cloud computing are the two giants in the latest trends in the market. Nowadays, all the companies are using these two technologies because cloud is used for storage of data and as well as in order to compile the data, execute the data, and deploy the data. For backbone, we are using cloud data storage for big data sets like Facebook, and streaming data, YouTube video data, audio data, text, graphics data in the data centers. And if you see the one small video, so that is the introduction about cloud computing. If you see the cloud computing is a metaphor for the internet. Metaphor is nothing but consists of related terms to internet. Internet is developed by Bold, Bernard, Newman. Three scientists has been proposed. Internet, network of networks, Network is a interconnection between the autonomous computers. That those are the LAN, WAN, MAN, local area network, wide area network, and metropolitan area network. Cloud computing is a internet-based computing. I told you, without internet, there is no service of any kind of application, software, hardware, infrastructure, etc. Cloud computing is a multi-tenant architecture. Multi-tenant is nothing but multiple users are connected to the cloud and we are accessing the information. If you connect it to the Amazon, we are accessing the infrastructure as a service. If you connect it to the Salesforce, we are accessing the software as a service. If you are connecting to the MS Azure, we are accessing the platform as a service. It provides the resources that are as services. These services are on-demand service that is called pay and use. That's why I used to call it as cloud computing is a pay and use. Cloud computing is a form of distributed computing because we are storing huge computing servers at different locations for different purposes, and you can access from anywhere, anytime, 24/7 you can access the service. The heart of the cloud computing is internet and virtualization. Internet is a network of networks. Virtualization is the ability to perform multiple tasks in a single system. There are popular virtualization technologies are VMware, Hypervisor, Zen, Virtual Iron, etc. Cloud computing has two important sections. First one is front end with thin client or desktop or laptop, and back end we are having data center. Front end includes the computer, internet, and end user. Back end includes data center and with the help of virtualization software. Okay, then so data centers with eternal connectors. I am going to show you the data center, Google data center. You can't imagine such a huge computing power, the integration of servers at one place, just like a football court. Such a huge servers are presented. If you see in India, Indian Institute of Science, how many of you know a supercomputer? Indian supercomputer. Can anyone name it Indian supercomputer? Param. Param is an Indian supercomputer which is developed by CDAC company and it is located at IISc Bangalore, Indian Institute of Science, Bangalore. And if you see the data center is nothing but collection of high integrated computing servers at one place, because I would like to execute a huge volume of data real-time application. I require high computing power. That's why I'm using Amazon EC2 and S3 clouds. And multiple users are connected now. So cloud computing, so I'm connecting with the PC and you are connected with the server, or they are connected with the network, and they are connected with the database, they are connected with the mobile, etc. And if you see the beautiful definition revealed by John McCarthy in the year 1979, cloud computing is a model for enabling ubiquitous. Ubiquitous means everywhere technology is presented. Convenient, on-demand network access to a shared pool of configurable computing resources. Shared pool of is nothing but combination of network, server, storage, applications and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. Why do we choose cloud computing? In order to reduce the cost, because no need to purchase a physical servers, no need to purchase a software, no need to do maintenance. We are taking license from the big giants like Google, Microsoft, Facebook, various big companies, and we are using that service to our application particular time. Cloud, and when this cloud computing term introduced in India, Ramanathan Chellappa is from Karnataka, is working as a faculty at IISc Bangalore. In the year 1990, he introduced cloud computing term. Cloud computing is a style of computing in which massively scalable IT related capabilities are provided as a service. As a service, massively scalable means size is not a limit. We are dealing with a huge volume of data, terabytes, petabytes, exabytes, and yottabytes, zettabytes. What kind of huge volume of data we are handling in the real-time environment? Then as a service, nothing but services are not a limit. You can have a software as a service, platform as a service, infrastructure as a service. Anything can be as a service, technology as a service, database as a service. Anything can be as a service. Using internet technologies to multiple external customers. This is the beautiful definition given by the Ramanathan Chellappa. I am giving the cloud computing is a 5-4-3 formula. 5 is nothing but 5 characteristics and 4 is nothing but 4 infrastructure models or deployment models, and 3 is nothing but 3 major services. And if you see the 5 characteristics, what are the 5 characteristics? OBR square M. O stands for on-demand computing, B stands for broad network access, and R stands for resource pooling, and one more R stands for rapid elasticity, and one more and M stands for measured service. On-demand computing is nothing but pay and use. I don't have IBM DB2 software in my laptop, but I want to run my database application with help of DB2. What can I do right now? I am taking license from the IBM company. I am paying 500 rupees for 500 hours so that I can execute my application within 1 month. That is the greatness of cloud computing. That is called on-demand computing. That's why I'm giving my caption is pay and use. Cloud computing is nothing but pay and use. And broad network access is nothing but 24/7 we can access the service from the any cloud. Resource pooling is nothing but we are storing all services at one place is called resource pooling. Rapid elasticity is nothing but we are increasing the size. Obviously, we are increasing the servers automatically data center. Measured service means how much service you are consuming, that much amount you need to pay. Best example is electricity bill. How much per month we are paying electricity bill based on the consumption. Then 4 infrastructure models called public cloud, private cloud, hybrid cloud, community cloud. Public cloud is nothing but everybody can access, and any cloud, from any cloud you can access the any kind of service. That is called a public cloud. Private cloud is nothing but only private employees of that organization, the people are accessing that information. Remaining, they are not allowed to, they are not authorized to access the information. That's why it is called private clouds. Then hybrid cloud, combination of 50% public cloud, 50% hybrid cloud, I mean private cloud. Then community cloud is nothing but only software people, only BCA students of Annai College of Arts and Science, they're accessing the cloud. Only computer science students are accessing the particular information. That is called community cloud. Intercloud is nothing but nothing but network of clouds. I mean network of clouds is nothing but intercloud. Within the organization, there are sub clouds are presented. There are 3 major services such as SaaS, PaaS, IaaS. Software as a service. I don't have a DB2 software. I am taking license from the Amazon company. IBM company. So Gmail is a best example of application of software as a service. So the number 1 cloud under software as a service cloud is salesforce.com. Platform as a service cloud is nothing but where I am writing a code and compiling the code, executing the code, finally deploying the code. Such type of platform is called a platform as a service cloud. Best examples are MS Azure, Google App Engine, etc. Infrastructure as a service cloud. I don't have 1 terabytes of space in my laptop. I'm taking license from the Amazon company. They are providing 1 terabytes of computing power to my system. Whenever I'm logging into the system, automatically I'm getting the service because I have taken the license from the Amazon EC2 and S3 clouds. Those are the best examples of infrastructure as a service cloud. And if you see the prerequisition of cloud computing is nothing but, and data is a raw material, information is nothing but the processed data, and the collection of interrelated data is called database. Collection of, to manage the database, we are using relational databases such as SQL, MySQL, Teradata, DB2, MS Access, etc. To store huge volume of data and a collection of marts. Collection of marts is nothing but data warehouse, and OLAP is nothing but data warehouse, online analytical processing. Data warehousing tool, the popular data warehousing tool is Informatica. Nowadays we are using in big data Hive and HBase. Data, after storing huge volume of data in the servers, what you can do? So I'm extracting meaningful interested patterns from the data center. That is called data mining with the help of classification, clustering, association, rule mining, outlier detection, recommender engine, various techniques I'm using to extract the meaningful data. That is called a data mining. There are various data mining tools are there. Weka, R, MATLAB, RapidMiner, Orange, Gobi, various tools are there, SPSS, SAS, etc. Then cloud computing. Cloud computing is a 543 formula. I have explained 5 characteristics. 4 infrastructure models, 3 services. Without internet, we cannot access any kind of cloud information. That is called pay and use. After that, big data analytics. It deals with the 3 V's. Volume, velocity, variety. Volume says that what is the size of the data we are handling in the real-time environment. Terabytes, petabytes, exabytes, octabytes, what kind of latest terminology of measuring the data. Then variety. Variety is nothing but what kind of file we are handling in the real-time environment. Whether we are handling XML files, HTML files, flat files. What is meant by flat files, my dear friends? Be interactive. What is meant by flat files? Anyone? Madam, my voice is audible?
Yes, sir. Yes, sir. Your voice is audible.
Yeah,
You can proceed,
please.
sir.
Yeah.
Okay.
Participants, kindly post your queries in the chat box.
Yeah,
Be-
please. Any doubt, you please ask me. I'm going to clarify and give example. Yeah. Please give me example for flat files. How many of you know flat files? Okay. At the end of the session, I think you are hesitating to ask any question, so that I'll clarify last 15 minutes. You can ask any question. Flat file is nothing but XML file. You can take a document file, spreadsheet, okay, and PowerPoint file and MS Office. These kind of files are called flat files. So then velocity says that the speed at motion. Okay, the way we are downloading the files, uploading the files, whether we are handling the legacy data, world data, or streaming data, or real-time data, near-time data, what kind of databases we are handling, that is called velocity. Then finally, the latest trend in the market is data science. Data science is the process of examining and extracting insights from huge volume of data from the unstructured data, structured data with the help of scientific methods and algorithms and techniques, machine learning techniques and deep learning techniques. That is called data science. This is the prerequisition chart for cloud computing and big data. So can anyone answer for this? What is the technical name of this logo? I am asking the question. What is the technical name of this logo? Anyone?
Kindly post your answer in the chat box.
Yes, please. So everything is incorporated in this image. If you see this image incorporated with software, internet, government, management, and petabytes, information, storage, and everything we have incorporated, and backup, disaster recovery, and virtual desktop application web. Everything is incorporated in this one. This image technically, because we are technical students, we are IT background students, you must know the technical name of this logo. This image is called Word Cloud. The name of this cloud is called Word Cloud. See here, the cloud, and this is called Word Cloud of big cloud and big data. This is the technical name. See, how do we measure the data in cloud computing? What is the backbone of cloud computing? Data center. Data center is nothing but collection of 5 integrated servers at one place is called data center. What is the size of the data we are storing? Computer understands only ones and zeros. 1 bit is equal to 0 or 1. 4 bits is equal to 1 nibble. 8 bits is equal to 1 byte. 4 bytes is equal to 1 word. 4 words is equal to 1024 bytes. So 1024 bytes is equal to 1 kilobyte. After kilobytes, megabytes, gigabytes, terabytes, petabytes, hexabytes, octabytes, zettabytes, and yottabytes. Hi, I am Robo. My speed is 1 zettabyte. My memory is 1 yottabytes. That means before that Robo movie, we don't know the measurement of the data. This is unfortunate thing. After that Robo movie only, we come to know. So, oh, this much terminology we are using for measuring the data. Yes, that is true. Thanks to Shankar sir and Rajnikant sir. They have introduced the terms zettabyte and yottabytes. So, hi, I am Robo. My speed is 1 terabytes and my memory is 1 zettabyte. See, yesterday night, again I have searched, is there any terminology to measure the data? Yes, there are 2 more terminology. 1024 zettabyte is equal to 1 yottabytes. 1024 yottabyte is equal to 1 brontobyte. 1024 brontobyte is equal to 1 geobyte. Not JIO geobyte, my dear friends. It is a geobyte. That JIO geobyte ruined a student's life. And students are not studying these days. They are addicted with Facebook and WhatsApp because of that Geo giving such a cheap internet facility in India. Okay, so if you ask me 1024 geobyte is equal to how much? I cannot answer. There is no terminology. Infinity. This is the way we are measuring the data in cloud computing environment. If you see in mathematical, normal range versus big data range, kilobyte is 10 power 3, megabyte is 10 power 6, gigabyte is 10 power 9, terabyte is 10 power 12. If you see same mathematics range in big data, 10 petabyte is equal to 10 power 15, exabyte is 10 power 18, zettabyte is 10 power 21, yottabyte is 10 power 24. If you take 1 brontobyte, 10 power 27. If you take geobyte, 10 power 30. This is the way we are using the measurement, the data in cloud computing environment. My dear friends, if you are having any doubts, please post in the chat box so that I am going to clarify you. And the cloud computing services, see here, cloud computing service features. If you see the cloud computing features, pay as you use, like electricity bill, security, you are using Gmail account, there is a security. Gmail is a best consumer of cloud, and Google App Engine, we are using various clouds. 24/7 support. That means where you wake up at 1 o'clock, you can use Gmail, it will open because of 24/7 support. Location management, it is not depends on only particular location, it will no. It will open everywhere, anywhere, anytime. That is called pervasive computing. Pervasive computing is nothing but everywhere technology is presented. Then device management. So you can use tab, you can use server, you can use computer, you can use mobile, anything. Highly automated. Nowadays, we can see the all applications, all even ATM is an automated application because of cloud environment, it is working. Lower expenditure because we are not purchasing any software, hardware or any maintenance. We are taking license from the cloud computing. That's why we are getting lower expenditure. And freeze internal resources. Free. All the softwares nowadays we are getting free of cost. Only commercial softwares we are not using. And you can use Linux, Hadoop, Spark, and Unix, Linux, everything. Fast, free open source softwares. Then storage management. See, Google is giving 12 gigabytes of 12 GB, 20 GB, depends on your application. You can purchase from the Google, but they are giving free storage management. Then reliable, that means anytime, anywhere, any particular time, it is giving reliability. Lower TCO, total cost ownership. If you invest 1 lakh, you are getting 1.5 lakh profit. Pay as you use, that is the caption of cloud computing. Then see the cloud computing. With the help of cloud computing, I am storing my photos in the internet, that is cloud. Internet is nothing but network of networks, that is developed by Bold Bernard Newman. Location, anywhere you can use. Music, Wink, best example, Wink music, that is a cloud environment. Videos, YouTube is a best example of streaming database with help of cloud. Then games, we are playing online games with help of cloud computing, and we are using Gmail. I have already explained Gmail is a best consumer of cloud computing, and this comes under software as a service cloud. Then social media, we are using Facebook, WhatsApp, and tweets, Instagram. These are the social media. Wi-Fi. Wi-Fi is nothing but wireless fidelity. You can use Wi-Fi technology with the help of cloud computing environment. Global, everywhere is presented. That's why it is called pervasive computing. Then cloud computing components. What are the cloud computing components? So virtualization. Virtualization is the ability to perform multiple tasks in a single system. The popular virtualization technologies are VMware, Hypervisor, Zen, Virtual Iron, etc. With the help of VMware, we can install 2 operating systems at a time. 2 tasks we can perform at a time. Then multi-tenancy. Multi-tenancy is nothing but multiple users are connected to the cloud. We are accessing the cloud information. Then cloud storage. We are, as end users, customers, we are storing our data, photos, audio, video, text, anything files related to the personal, we are storing in the cloud environment. Hypervisor. Hypervisor is nothing but it is one more version of virtualization. With help of a hypervisor through Microsoft, we are doing virtualization, that is called Hyper-V. We can create n number of virtual machines. So you are a Gmail user of Gmail cloud. That's why you are an instance of that cloud, that is called Google Cloud. That's why your Gmail account is an instance, that is called VM. You are a VM of Google Cloud, that is called hypervisor. Cloud network. So suppose I am using 2-3 clouds at a time, that is called cloud network. I am using software as a service cloud. I am using a platform as a service cloud. I am using infrastructure as a service cloud. Then platform is nothing but I'm using MS Azure, Microsoft platform. I'm using .NET programming language, and I'm writing .NET code, compile it and execute, and finally deploying the application in the MS Azure. Then that is called cloud components. Then cloud computing service models. Majorly 3 service models I have already explained. Infrastructure as a service cloud. Best examples are EC2 and S3. Application, data, runtime, middleware comes under managed by the user. Then operating system, virtualization, server, storage, networking managed by the vendor. Vendor is nothing but Amazon, Microsoft, Facebook, Google, etc. Platform as a service. So application data, runtime, middleware, I mean only application data managed by the user, and middleware, runtime, middleware, operating system, virtualization, server, storage, networking managed by the vendor. Then software as a service, best cloud is salesforce.com, and application, data, runtime, middleware, operating system, virtualization, server, storage, networking managed by the managed by the vendor itself. That is the difference between SaaS, PaaS, IaaS. Then the rise of big data on cloud computing. Big data big data. Why it is called big data? Big data, traditional systems are unable to process the data. That's why we are going to the Hadoop and Spark environment in order to process the huge volume of data. That's why it is called big data. Big data deals with the huge volume of data. That is called volume, velocity, variety. So it is classified into data sources, content format, data stores, data staging, data processing. Data source stores is nothing but web and social, machine, sensing, transactions, Internet of Things. From these sources, we are getting the data. Content format is nothing but structured data. With help of relational databases, we are creating the tables and we are managing the database like SQL, MySQL, Teradata, MS Access, and DB2. We are creating the tables. That is called structured data. And unstructured data is nothing but audio, video, text, graphics, animation. There is no proper format. There is no schema. There is no procedure. And we are handling the database that is called relational-less databases called Mongo database, Hive, HBase, etc. That is called unstructured data. Semi-structured data is nothing but 50% structured and 50% unstructured data we are handling. Then data stores, document-oriented related data we are storing, column-oriented database we are storing with help of Mongo database, and we are storing, and graph-based we are storing like Facebook database, and key value like hash-based index database stores. Then data staging. Data staging is nothing but we are cleaning the database. We are pre-processing the database. We are eliminating the redundant data, noisy data, inconsistent data, dirty data, etc. That is called cleaning, normalization, transform. Finally, data processing is nothing but the way we are handling the large volume of data, whether the database is legacy or new. If it is legacy, we are using Hadoop environment through batch processing. If it is streaming database, better to use Spark framework, because Spark is 100 times better than Hadoop environment. That's why real-time databases we are using like Sensex data, like Bombay Stock Exchange data, National Stock Exchange data, and streaming data, and YouTube database, and traffic database, and Sensex time series database we are handling. Then the rise of big data on cloud computing. So the data sources we are getting from various sources and we are storing in the backbone of cloud computing like data centers. Through web we are accessing. Then we are performing analytics reports. See, we are using Hadoop environment to process the database. Then with the help of NoSQL like Mongo database, HBase and Hive we are processing. Then programming model, suppose you are familiar with Java, Python, Julia, R programming and various C, Java, Ada, Smalltalk 80, Lisp, Prolog, any programming language if you are famous, you can use. Then quality engine, like we are using Mahout library in order to process the classification, clustering, association, rule mining, outlier detection. Hive is a data warehousing tool. Finally, we are generating the reports. And finally, as a manager, principal madam would like to take decisions about Annai College of Arts and Science students. 2021, how many passed due to in the pandemic period. Madam would like to see the analytics with the help of pie chart, bar chart, and line chart. These are the data visualization purpose. We are using Tableau, R programming, MATLAB, Excel, etc. APIs is nothing but application programming interface. What is meant by cloud architecture? Cloud architecture is nothing but it is a structure which comprises the software and the hardware components and the connections among them is called cloud computing architecture. And see, cloud computing architecture consists of components and subcomponents and required for cloud computing. These components may be a front-end platform like a fat client, thin client, mobile device, and back-end platform like server, storage, internet, cloud-based delivery, and network like internet, intranet, intercloud. Combined, these components are called as a cloud computing architecture. Root of connectivity, hypervisor, management software, and server of the cloud, and storage of the cloud, deployment of the software. So if you see the diagram, cloud computing architecture, these are the 5 major components are there. Cloud consumer, cloud auditor, cloud provider, cloud broker, and these are the cloud carrier. These are the 5 major components of cloud architecture. Cloud consumer, we are the Gmail accounts user, all are comes under cloud consumer like Gmail. Gmail is the best consumer of cloud computing. Everybody utilizing Gmail service. Then cloud auditor. So cloud auditor responsibilities are security auditing, privacy impact auditing, performance auditing, and you can call it as a service cloud infrastructure like SaaS, PaaS, IaaS, and resource abstraction and control layer. Physical resource layer, we are using hardware and facility. Cloud service management comes under business support, provisioning and configuration, portability and interoperability. Interoperability is nothing but multiple operations, multiple platforms we can easily run with the help of cloud computing. And here we need to concentrate privacy and security. We can give you 99% of security privacy with help of security algorithms. Then finally, cloud broker is a mediator between cloud consumer and cloud provider. Service intermediation, service aggregation, nothing but is combining all the services called resource pooling, SaaS, PaaS, IaaS. Then service arbitrage, nothing but if I would like to access only infrastructure, yes, you can access in only infrastructure as a service. And the cloud carrier, so cloud carrier carries the cloud information. So these are the 5 components of cloud computing architecture. So I have explained already these terms. Then coming to the cloud security, our title is cloud security. So cloud security is the protection of data stored online. See, nowadays we are doing so many transactions, real-time transactions with the help of Phone Pay, Google Pay. So many pays we are using these days, but you are believing. So because of this cloud computing security only. So SBI, they are using cloud secure, they are moving their servers towards cloud computing because they would like to automate everything. So that's why these days all banks are giving online service 24/7. With internet, we are accessing the cloud security mechanism. So via cloud computing platforms, from theft, leakage, and deletion methods of providing cloud security, including firewalls. Okay, and you can use the testing. Okay, and penetration, tokenization, virtual private, and providing public internet connections, everything. Okay, so data security means the way you are storing data in the in SBI account, that is called data security. With the help of cloud security only, we are storing the secure. There are three types of security levels: data security, network security, host level security. So we are protecting our data in the cloud environment. Availability 24/7, I am getting the service with help of authentication security. Compliance and disaster recovery and backup connectivity planning and governance and identity and access management. Who is using your service? I am using IBM cloud service, I am using Gmail service, etc. So that is called cloud security. Cloud security report 2021. See, 33% admitted that they are extremely connected. 40% were very concerned about this cloud security. 20% were moderately concerned. 20% said they were not at all concerned about this cloud security information. If you see the in securing the cloud connected with identity and access management, who is accessing, how much accessing, when is accessing, where is the accessing, that is called identity and access management. Securing the operating system, that means I am using a Linux operating system, Windows operating system. So inbuilt with operating systems are coming high securing mechanism. Managing security, monitoring, altering, auditing trail, and incident response, etc. Protecting the network layer. So we are entering, see, you are entering into the internet through mobile, you are out of danger. That means, see, whenever you are connecting to the internet through mobile, you are in the danger. There are four sides of people are watching what sort of emails you are checking, what sort of websites you are watching, what sort of files you are downloading. Everything monitored by the particular cloud sensors. Okay, be careful while using internet in the mobile or your laptop. Introduction to the cloud security architecture. It consists of user security and monitoring, information security, data, application level security. 1 second. Hello? Hello? ಏನಣ್ಣ? ఆన్లైన్లో చేసేయచ్చు చెప్తాను, చేయొచ్చు ఆన్లైన్లో. తెలుసు నాకు తెలుసులే, నేను చెప్తాను. 1,25,000 ఉంది. నేను చూశాను. చేసేయచ్చు. సరే, నేను సెషన్లో ఉన్నా ఇప్పుడు, నేను మళ్ళీ చేస్తాను. నేను వర్క్షాప్లో ఉన్నా. Sorry. Okay.
Sir, you can stop the recording. Sir, session has been completed, has been over.
No,
Some
ma'am.
interaction.
Ma'am.
Some interaction is going on.
Yes,
Yeah.
ma'am.
Sorry for disturbance.
Okay, sir. No issues, sir. No
No
issue.
problem.
Welcome back. So these are the security architecture components like information security data, application level security, platform and infrastructure as a service security. If you see the user security and monitoring level, what we need to consider: identity services like you can use delegation, provisioning, supporting services, auditing like super user privilege management. If you come to the information security, we can use encryption and key management, ACL logging, etc. Application level security, application stack, service connectors, database storage, etc. Platform and infrastructure service, we are using PaaS services like NoSQL API and no structured query like Mongo database. Then a guest OS level, hypervisor, host level, network level. These are the on-demand security architecture for cloud computing. There are user level, network level, security, domain, and security center. See, in the bottom level, data center is there. Collection of high integrated servers are, that is called storage security domain. Then service security domain, we can consider SaaS, PaaS, IaaS services related. IaaS related hardware, virtualization, connectivity and delivery, and APUs. And then integration OS and middleware, that is called PaaS. And final conclusion, software as a service integrated with applications, APIs, content, application program, interfaces. Then if you see the on-demand security architecture for cloud computing, so this is one more on-demand security architecture by the one more giant in the market, cloud. They are using security services infrastructure, security services application oriented. If you see the left side, security, strategy, architecture, governance, business, connectivity, we are concentrating with the data center and bring your own stack, that is called BIOS. And in the middle, we are using infrastructure service, automated operations, virtualized infrastructure. If you see the right side, we are using identity management, access management, and risk of cloud computing. You can say some facts like how much data we are protecting in the Gmail account or SBI account. Okay, so some facts related to cloud security. Then risk. What is the risk? If you are using internet banking or online mobile banking, then measures and controls. What are the measures we are taking to control such type of cyber security issues in cloud environment? And what are the precautions we are taking in order to protect our online accounts? Then what are the encryption mechanisms we are taking in order to high level protect of the data? Then what is by cloud computing security? The goals of security services are privacy, authenticity, integrity, non-reputation. Integrity is nothing but we are using different cloud services for different purposes. Authenticity is nothing but who is the user and what is the name and what is account, what is identity. Then integrity, integrity is nothing but integration of two or more technologies. Availability is nothing but 24/7 I am getting with a secure manner. Confidentiality, whether I am handling my online account with the confidentiality or not. Then cloud computing security requirements. What are the requirements I am using cloud security environment? Access control, authentication, content screening, user monitoring, production of web services, production of database, proper use of IT resources, securing messages. So these are the requirements we need. We require physical servers, internet, third party, browsers, okay, then cloud service providers related to SaaS, PaaS, IaaS, and anything can be as a service. Then cloud computing security aspects. What are the aspects we need to look into this security cloud environment? Technology, management, operation. Whether we are using physical services, physical security required. Whether we are using network services, network related services. Host security, I can use my own server. Application security, what type of application I am using, internet banking application, Gmail, or any kind of software application. Security policy, what type of policy particular cloud environment is giving. And audit, what is the audit of particular cloud environment. Then security awareness, every consumer, every user must know the awareness of security levels in the aspects. Then coming to the cloud computing security anatomy. So cloud server is there. Collection of high integrated servers, high computing servers at one place is called data center. Cloud controller controls the node. Node is nothing but a computer or server. Usually we can call it as a virtual machine. So with the help of VMware hypervisor, Zen virtual iron, we are creating n number of virtual machines in a data center. Then if you see the best example, anatomy of cloud computing security, who is the user, what type of portal you are using, whether you are a mobile user, computer user, or tab user. Then cloud controller controls and giving signals to the image repository where we are storing, compute servers where we are storing the data center, and block storage. This is the data storage we are storing in the data center. Then cloud computing security issues. What are the security issues are there? There are many security data location. See, 2004, Sony company lost their business, 80% of business lost due to natural calamity like tsunami. Tsunami came at Indonesia. Tsunami came from Sumitra River. It started in the year 2004. So due to natural calamity, Sony company lost their business 80%. That is called data loss. Downtime. Sometimes Annai College of Arts and Science server is not working because all are checking their results in the internet. That time the server goes down. That is called downtimes. Password cracking. So there are many passwords cracking that is comes under cyber security issues. Then botnets and malware and robots. So automatically they are reading your data. Botnet is nothing but a robot. Intelligent behavior in a machine. That is called botnet. Chatbot. Alexa, best example. Alexa, voice assistant. Recently, humanoid robot like Sophia, Zia, Junko Jahira, these are the humanoid robots. Sophia took the citizenship of Saudi Arabia and Dubai. So those humanoid robots are stealing our data. They are entering into the network level intruders. They are catching our data. They are catching, they are seeking our data. Loss of control. Sometimes our websites and organizations loss of control. Multi-tenancy, everybody knows. Multiple users are connected to that cloud. So security problems with the cloud computing like privileged user access, data location. It is not depends on only one location, everywhere. Data may loss. Data segregation, we are classifying the data. Recovery, we are recovering the data. Investigate support. And long-term viability and regulatory compliance, various security problems. See, there is one website revealing where is security threat happened. Where is the website out of control? These security instance showed by the cloudtaste.com. So, my dear friends, you can use www.cloudtaste.com. You come to know where the incidents happen. So recently Amazon and Google due to ransomware, some companies, they lost their control on their websites. So Microsoft 2000 to 2009, T-Mobile lost data in the mobile. Downtimes happened for Amazon in the year 2008. Nobody accessing their cloud data center, no availability, power supply. So these days, those problems are resolved. Password cracking, Amazon EC2 2009, it happened. So botnets and malware, lack of trust, loss of control, multi-tenancy, these cybersecurity incidents are happening. Only one website is going to reveal such type of information is called cloudtaste.com. Securing cloud data with see, how do we secure the data? Data loss with help of Bevo app. Through mobile, we are accessing the information. External threats, internal threats, data abundance, data civility, regulatory compliance, data privacy. These are the cloud data. There are three types of security issues in the cloud environment. Those are the data level security, network level security, host level security. In order to protect our data, we are using security algorithms like AES algorithm, RSA algorithm, proxy, two-way authentication, etc. And a few more. In the network level, we need to protect our data. We are using DES algorithm, firewalls, NSA, and belief logic because of data loss, loss of control, lack of trust, multi-tenancy. Benefits of data security. So reliable data for decision making. Yes, 24/7 we are securing our data. Faster detection and remediation of threats. With threats, we are protecting our data. Then reduction of insider fraud, theft, and data leakages. So we are protecting our data. Improved regulatory compliance, protects business reputation, promotes operational benefits. These are the benefits of data center. Then what are the risks of cloud computing? I have already explained. Privacy, availability, changes, compliance. Still, R&D is ongoing on these issues. Privacy, availability, changes, compliance. Then cloud security, I have explained already some facts, risk, measures and controls, precautions, encryption. So cloud computing security, you can call it as cloud computing risk and challenges. What are the challenges? In every private cloud, there is a challenge. Public cloud, there is a challenge. Hybrid cloud, there is a challenge. Efficiency, best example. The characteristics, OBR square M. O stands for on-demand computing. B stands for broad network access. R stands for resource pooling. One more R stands for rapid elasticity. And M stands for measured service. Then scalability is nothing but we are increasing the size of the data in the data center. Cloud computing application and databases. There are numerous applications we are using with help of cloud databases, cloud storages, CRM, customer relationship management database, communication and collaboration, office productivity and suites, financial and accounting applications, medical imaging database, patients, urgent care information, online storage management, various applications of cloud environment. If you see Salesforce, Gmail, Google App Engine, video streaming like YouTube, application development, these are the applications of cloud computing. And a few more cloud security tools we are using. And Qualys, Okta, Zscaler, Proofpoint, White Hat, Cipher Cloud, Doc Tracker, Contrify, Valuity, Silver Sky. These are the various secure cloud security tools we are using in order to protect our data in the network level. 5 best cloud computing tools and technologies. like migrating the data from one server to another server, analytics we are generating, and technologies we are using big data technologies, we are using hosting, and we are using discovering patterns with help of machine learning, deep learning, and data science applications, and artificial intelligence we are using, etc. Then these are the research aspects of cloud computing. Still, R&D is there, my dear participants. If you want to do any research related to cloud computing, I am going to help you regarding these 14 research issues like legal issues for cloud, compliance for cloud, governance for cloud, data security for cloud, network security for cloud, and interfaces for cloud, data shredding for cloud, proof of irretrievability for cloud, Hail is nothing but a high availability and integrity layer, multi-tenancy for cloud, loss of physical control for cloud, loss of control in the cloud for cloud. How can you write application for all data centers? How many mirror sites in globe of service provider? These are the 14 research challenges. If you want, you can give these challenges to your final year students. They are going to implement and they are submitting their project. My dear faculty members, if you are having any doubts, you please you can ask after end of this session. I'm giving these 14 challenges, and if you want my assistance, I'm always available, and I'm going to share my PPT to your coordinator. Madam will share to you, and she will share my contact my contact mail and mobile number. Okay, then now the term comes to the big data technologies, how we are cloud security using big data technologies. See, the backbone of cloud computing is a data center. Data center is nothing but a collection of 5 integrated servers at one place is called data center. Big data deals with the 7 V's are there actually. Volume, velocity, variety, veracity, value, visibility, viscosity, and validity, etc. Then cloud computing is a internet-based technology. It is a 543 formula. Without internet, we cannot access any kind of service. I think big data, everybody knows. I have already explained high volume, high velocity, and high variety information assets that demand cost effective, innovative forms of information processing for enhanced insight and decision making. So big data is deals with the large data sets such as Facebook data set, Twitter data set, WhatsApp data set, streaming data sets, traffic data sets, time series data set, weather forecasting data set. It is a too large, too complex and dynamic for any conventional data tools to capturing the data, to store the data, to manage the data, to analyze the data. These are the 3 important characteristics. I have already explained. Data volume says that size of the data, megabytes, gigabytes, terabytes, petabytes. Then data variety means what kind of file we are handling in the real-time environment, audio, video, text, graphics, animation. Data velocity says that what kind of data we are handling, whether we are handling real-time data, near-time data, periodic data, batch processing, etc. And why do we want to study cloud and big data? Everybody gets the doubt. If you are having more data, it leads to the more knowledge. More knowledge leads to the more money. Definitely we are increasing the business. Definitely we are getting the more money. See, big data analytics, generating interested analytics. It is the process of examining large amounts of data of a variety of types like big data sets to uncover hidden patterns, unknown correlations, and other useful information. So that's why we are studying big data, cloud computing, artificial intelligence, machine learning, deep learning, data science, etc. My dear faculty members, if you are having any doubts in any latest technologies of IT field, you can contact me. I am going to help you. Then this is the, what is the technical name of this big data? I have already explained. First slide. Everything we have incorporated in this slide. See, information is there, network is there, technologies are there, storage is there, sets, ability, complex databases. This is called a big data word cloud. Big data, the technical jargon of this image is called a big data word cloud. Then the myth about big data. Big data is new. Big data is only about massive data volume. Big data means Hadoop. Big data need a data warehouse. Only. Big data means only unstructured data. Big data is for only for social media, sentimentals. No. These are the myths about big data. Big data can handle any kind of data. Okay. What is big data? Large amounts of data. Traditional systems are unable to process the data. That is called a big data. Collected passively from digital interactions from various organizations with great variety and a high rate of velocity. That is we used to call it as terabytes, petabytes. Such type of data is called big data. You may get, sir, which type of data we used to call it as a big data? Traditional systems are unable to process the data. Such data is called big data. That's why we are going to handle the big data with the help of Hadoop, Spark, MATLAB, etc., Python, etc. tools. Then these are the 4 V's I am giving: broadly classified, volume, scale of data, velocity, analysis of data flow. Veracity means uncertainty of data. If I am asking you, my dear faculty members, please give me 0 to 1, the value. Madam is saying 0.7, one more madam is saying 0.1, one more madam is saying 0.5. Which data I have to consider? That is called veracity, uncertainty of data. Variety means what kind of file I am handling: audio, video, text, graphics, animation, etc. That is called variety of data. Then I have explained this one already slide. Then when this big data came in the year 1990, CRM and ERP came. Then 2010 came Web 2.0. Then 2015 onwards, big data came into the market. We are using 90% unstructured data, 10% structured data we are using. Okay, so big data, if you take Facebook alone, it is generating 1000 terabytes of data daily. Whereas many other organizations like Jet Airways, YouTube, stock market, etc. There are 3 types of data we are handling in the real-time environment. That is called structured data. I have already explained. With the help of SQL, MySQL, we are managing the database. We are creating the database. That is called structured data. With the help of Hive, HBase, Mongo database, NoSQL databases, we are creating the database is called unstructured data. That is called audio, video, text, graphics, animation, etc. Semi-structured data, 50% structured data, 50% unstructured data we are handling. Then big data matters for data growth is huge and all that data is valuable. Data won't fit for a single system. That's why we are using cloud and distributed computing. Why distributed computing? It is a faster computation because different locations connected by the internet. Big data matters for aggregating the data. We are generating the statistics. We are indexing the data, searching for the data, querying the data, and discovering the data and knowledge. So where the data is coming from various sources like bank. If you take bank transactions, we are getting so much volume of data. ERP data, public data, social media data, sensors media data, and big data in marketing, cameras data, machine sensors, microphones, etc. So big data is everywhere and it can help organizations, any industry in many different ways. These are the sources: enterprise data, public data, sensor data, social media data, transaction data. There are 3 types of tiers in the structure of big data. First one is data sources, where structured data, unstructured data, what kind of data you are giving input to the system, and what kind of technology you are using: Hadoop, Spark, Hive, MATLAB, Python, MapReduce, etc. What kind of analytics we are generating with help of pie chart, bar chart, line chart, and histograms, etc. Principal madam would like to see the only analytics per year. What is the pass percentage? Per year, how many students are getting jobs? So analytics we are generating. Then file formats I have already explained. There are various kinds of file formats are there. Audio, video, text, graphics, animation, documents, books, flat files, SQL, DB2, various kinds of files. I have explained already 4 V's of big data. Volume, the amount of information available; variety, various data sources collected; and velocity, how fast data is generated and collected; veracity, the degree to which data can be trusted. And these are the characteristics. Data at rest is called volume, data in motion called velocity, data with multiple formats called variety, data fuzzy and cloudy is called veracity. These are the 7 V's I have explained already. So visibility, validity, value, veracity, variety, velocity, volume. So these are the 7 V's of big data. What are the advantages and disadvantages of big data? So understand customer needs better. That is the one advantage. We are reducing cost because we are not purchasing any physical server or software or maintenance. That's why it is a great advantage. Then detect risks and check frauds, make processes more efficient, etc. According to the Gartner survey, Gartner is a famous surveyist. He is revealing every week, every month, which is the best software in the market, which is the best technology in the market, which best antivirus software in the market. Like that, Gartner survey, according to the Gartner survey, data complexity is the #1 place in challenges of big data. Then data volumes, then performance, skills, data velocity, cost, etc. So data protection, how we are protecting data with help of big data technologies in the environment of cloud. Internet security, it is a very cyber security issues are there. In order to protect our data, we are using internet security mechanisms. Big data security introduces how the data is securing in the data center. What is the implementation mechanism we are using? What are the technologies we are using in order to protect data? Then use cases. Who are the big companies are using data? Then what are the issues of big data? Okay. Threats in cloud computing like security, privacy. See, security. You can call it as a security 8%, and you can call it as a unclear ROI 30%, and privacy concern 6%, threats, lack of features, okay, immature technology, legacy integration, that means old technology. Then big data security issues, access controls, there is a problem. Who is accessing data from the cloud? Non-relational data stores. So we are using Mongo database, Hive, HBase, that is called non-relational data stores, Hive and HBase. To store the data, to process the data, we are using Hadoop, MapReduce. To store the data, we are using HDFS. Okay, Hadoop distributed file system, storage, endpoints, real-time security, data mining solutions. So security analytics, these days we are generating security analytics in cyber security with the help of cloud computing and big data technologies. Market opportunity, 74 billions in 2017. So advanced threats, still there are problems like data security, analytics security, and fraud, mobile, cloud, various security analytics and big data use cases, all these are. Then big data security use cases. So what are the major use cases which companies they are using? Cloud security monitoring, yes. Network traffic monitoring means how many users are connected, what kind of data they are handling, how much data they are consuming, like that. Network traffic analytics, insider threat detection, threat hunting, incident investigation, user behavior analysis, data exfiltration detection, everything. These are the big data security use cases. These are the research issues on big data analytics, sentiment analysis. I'm going to reveal you the recent application of sentiment analysis. How many of you know Joe Biden? Joe Biden is the president of USA. How he won the elections because of big data analytics, played a vital role in the background. 50 states are there in USA. 50 stars in the flag. So in 50 states, Joe Biden gave electronic voting systems like SMS and e-voting system. Okay, so the people accepted all that SMS and voting system. They voted for Joe Biden. Joe Biden opposite. So total out of 50 states, 45 states Joe Biden got majority, 5 states lagging. So what he has done, there are 16, 5 to 6 research data scientists and data analysts sit together. They have collected data from the 5 states where Joe Biden is lagging in that place, and they have collected data and stored in the system. They have applied prediction techniques, how to increase opinion or sentiment about Joe Biden. So they have given the boons like free current, free rice, free internet, everything they have given in the 5 states. So definitely the people attracted to those boons. So after the elections, Joe Biden won because of big data analytics played a vital role. That is an example of sentiment analysis. Opinion mining also, predictive mining, pre-clustering, post-clustering. How can we capture and deliver data to right people in real time? How can we handle variety of forms and data? How can we store and analyze data given its size and computational capacity? Okay, and these are the challenges I have already explained. Volume, veracity, data quality and accuracy. Viscosity means data complexity. Variability is nothing but data flow inconsistency. Volatility is nothing but data durability. Viability is nothing but data activeness. Validity is nothing but data properly understandable. Variety is nothing but different files we are handling. Heterogeneity. What are the big data tools? There are various tools we are using: Hadoop, Spark, Kafka, and Hive, HBase, Flink, Informatica. So these are the various big data tools we are handling in the real-time environment. What are the applications of big data? So if you are having any doubt in these tools also, you can ask me. So why we are using Kafka? For communication between messaging service, high throughput distributing and messaging. Why we are using Scala? Scala is a programming language in Spark framework, and HBase, it is a database language. The streaming, Flink is a streaming database. Informatica is a data warehousing tool. Tableau is a visualization tool. Solar is a search and index tool. Spark is a data analytics and streaming language, streaming framework, and data platform, data storing platform. Hive is a data warehouse. And these are the various applications of big data: social network, cyber security, IoT, retail market, retail banking, real estate, trading analytics, etc. These are the various applications of big data in real life: banking and securities, media and entertainment, insurance, transportation, education, manufacturing, energy and utilities, etc. And these are the various applications of data, big data analytics: smart healthcare, multi-channels, traffic control, trading analytics, fraud and risk, and retail market, search quality, log analytics, manufacturing, etc. And these are the big data applications in different sectors like banking, healthcare, education, government, retail, transportation, insurance. Wherever the data is presented, we are applying big data technologies application. Rising big data technologies like Hadoop, Spark, MongoDB, Cassandra. Cassandra is a data warehousing and database tool. Apache Kafka. Kafka is a messaging tool. ClickView, ClickSense, Tableau. Tableau is a visualization tool. Apache Storm, Apache Hive. Hive is a data warehousing tool. Apache Pig. Pig is a very popular language for streaming. Data flow language, especially all companies are using Pig programming language. It is a streaming language, data flow language. Presto, Apache Flink, Scoop, RapidMiner, Nime, various tools are there. What are the top 10 best big data analytics tools? Tableau, Cloudera, Teradata, R Programming, Spark, Lumify, Talent, Microsoft HD Insight, Skytree, Pentaho. These are the few more tools like data storage and processing tools. For data analytics tools, data warehousing tools, Hive. And NoSQL database, that is called Cassandra, Mongo database, Hive and HBase. Real-time processing, we are using Spark. Messaging system, Kafka, etc. How big data tools can be help you? Hadoop, it is used to store, process and analyze big data. Yes, we are using Hadoop environment for batch processing, legacy database. Spark, it supports in-memory computations because of in-memory RAM. Every time it loads from RAM only. First time it loads from hard disk. Then every time it loads from RAM. That's why it is so fast, 100 times better than Hadoop. Then Storm, it efficiently processes unbounded streams of data. That is called Storm. Then Cassandra, it provides high availability and scalability. Size is a matter. Size is a limit. You can increase a huge volume of data. Then Mongo database, it provides a cross-platform capabilities. That's why we are going for Mongo database. Cross-platform capabilities, keep in mind. Then selection of tools, big data tools, selection of platforms and programming. Like if you see commercial and open platforms like SAS, Veka, Nime, Orange, RapidMiner, SPME, IBM, SPSS, SAS, etc. Then languages and programming platforms like R, Java, Python, MATLAB, etc. Big data programming tools like Hadoop, Spark, Cloudera, Mahout, etc. Okay. Then cloud computing versus big data analytics versus IoT. If you see cloud computing, we are having infrastructure federated hybrid like Amazon services, Google Cloud platforms, then big data like Spark, Mongo database, okay, servertization like big data analytics, then IoT, Internet of Things, industry IoT, Internet of Things, IIoT, deals with the collection of real-time objects in a network is called IoT. Open hardware, low power, connectivity, then connectivity, low power, wireless. Then big data in the cloud. See, for big data technologies, the backbone is cloud computing. Cloud computing backbone is data center. Without internet, we cannot access any kind of service or application. Without data, there is no database applications. Without data, there is no data science applications. So how the integration between big data through cloud computing through big data technologies, this is the best scenario of this diagram. Then big data security and privacy, data management, how we are protecting the data, integrity and reactive security, how we are integrating 2-3 services, data privacy, how we are protecting our data, infrastructure, how we are storing in the IaaS service. Big data cloud. So big data stores in the data center. It is connected with all the text here. Put text here, your text here, put text here, text here. Everything is connected to the internet. Wherever data is called big data. Okay. So these are the challenges, science challenges, Earth Club goals, cloud resources, big data and cloud computing examples, funded projects. Okay. Domain science grant challenges, reproducibility, isolated data repositories, etc. So resources like modeling and virtualization apps, high performance computing HPC capabilities, data management tools, and etc. So cloud-based big data. Cloud-based big data is nothing but CRP, CRM, customer relationship management, ERP, enterprise resource planning, and education data warehouse, analytics and insights, financial data, weather data, commodities means various services, various applications, industry data. These are the data services done by the cloud-based big data. Okay, big data security technologies like encryption, user access control, physical security, centralized key management. I have already explained these technologies. Use big data and cloud computing for businesses. Yes, in big data, we are using reduction in fraud, search engines, e-commerce, benefits of online publishing, helps in recruitments, log analytics, and cloud computing, mobile, sharing the information, services, development and test, data backup. So cloud analytics, what are the cloud analytics we are generating? Data sources we are getting, analytics models, data storage or sharing, data models we are generating, processing applications, computing power. These are the cloud computing or big data, high capacity, low latency, low power consumption. Data center with services. Data center is a collection of 5 integrated servers at one place. It's called data center, operator service, and that is called decentralization. And the service platform, we are using transport, smart city, industry, building, automation, home, entertainment, etc. So this slide already I have explained. So big data technology areas, alternative visualization, big data, cloud apps, technology, SaaS, software as a service related. So cloud apps, technology, big data, SaaS as related, and big data, cloud serve, etc. This is a big data technology areas where we are covering. So big data technology area circle diagram means how this cloud, SaaS, big data connected each other. See, for big data, we need a data center. So in order to process the huge volume of data in the data center, we require Hadoop and big data technologies. We require softwares like IBM DB2, SQL, MySQL, Teradata, Mongo database, etc. That is called software as a service. Then cloud computing, big data differences between. Cloud computing is an internet-based technology and provides resources like storage, computing, database, monitoring tools, etc. on demand. Big data definition provides a way to handle huge volume of data and generate sites. Reference, it refers to internet services from SaaS, PaaS to IaaS. It refers to data which can be structured, semi-structured, unstructured. How they are used. It uses wide range of network of cloud servers over the internet to analyze data and information. It could be deployed either on premise or cloud to discover undiscovered patterns and generate actionable insights. Formats. Cloud computing is new paradigm to computing resources. It consists of all kinds of data which are in many different formats. Used for cloud computing, used to store data and information on remote servers. And used for big data, it is used to describe huge volume of data and information. And what is the difference between Hadoop and Cassandra? Hadoop is a batch processing of data. Cassandra is a real-time processing data, and master-slave architecture, distributed architecture, uses MapReduce, uses Cassandra query language between 10 to 15, up to 80%, difficult and easy, uses HDFS file system, uses key space column family concept, replication factor is 3, number of nodes in data center, access control, data audit, verify user group permission, etc. Data is reported with many log segments. So the Google and Hadoop, see Google and Hadoop developed by Google Apache, Hadoop developed by Apache company, sponsor Google, Yahoo and Amazon. Resource, open document, open source. File system, Google file system, GFS, HDFS, Hadoop distributed file system. Programming model, MapReduce, Google, Hadoop MapReduce. Storage system, Bigtable. Here HBase, Hadoop database. Search engine, Google, Notch. Notch is a search engine for Hadoop. Operating system, Linux, in Hadoop, Linux, and OpenGL. So cloud computing, big data, I have explained already this one. Latest research topics on cloud computing. Various topics you can incorporate. Nowadays, artificial intelligence, data mining, deep learning, machine learning, pervasive computing, okay, and various latest technology, IoT, cyber security, you can incorporate in these applications. 5 big data use cases: customer sentiment analysis, behavioral analytics, predictive support, fraud detection, customer segmentation. Challenges of cloud computing: security and privacy, interoperability and portability, reliable and flexible, cost, downtime, lack of resources, management of multi-cloud environment. What's next after cloud computing? So after cloud computing, there is a concept called edge computing, growth of complexity, specialized clouds, different patterns of technology, distributed ledger, cryptocurrency, and nowadays we are seeing blockchain technologies, supporting analytics, Internet of Things. And what is the future of cloud computing? Increased storage capacity, enhanced performance of internet, modular software will be priority. IoT along with cloud computing, data shows how future changes, improvement in cloud services, security, modular software, economic. These are the future of cloud computing. So this is my international conference at Thailand. This is my international conference at Bangkok and Malaysia. This is one more international conference and Malaysia, Philippines. This is my keynote speaker at Geetham, and this is one more resource person in the college, engineering college. This is one more resource person in the engineering college. This is acted as a jury member in the conference, and this is a keynote speaker at one of the engineering college. This is my doctorate degree from JNTU Anantapur. And this is Bharat Vidya Ratan Award from Delhi 2018. And this is ITAP Best IT Teacher of the Award in the year 2020. And this is a Best Local Chapter Award from IIT Madras. And this is International Seminar at Salem. And this is Big Data Analytics using Spark, Sangam University. And this is ABS College at Ghaziabad. Topic is Big Data Analytics with Spark. And this is Big Data Analytics using Spark at Jaya Engineering College, Tamil Nadu. And Big Data Webinar, Big Data Analytics using Spark, Maharshi Markandeya Engineering College. This is a Data Science Research Talk at Bluecrest University. Big Data Analytics using Spark at Oman, Saudi Arabia. And Data Science Applications hands-on. This is at Blue Crest University. This is COVID-19 strain virus detection using deep learning techniques at Russia, Ura Federal University. And this is today's symposium, Big Data Application using Spark. We have conducted and certification of participation, Ural Federal University. This is one more workshop. This is data science applications hands-on. Then one more invitation from Bhartiyar University, resource person. Then one more resource person at IT Career and Opportunities at Slots Institute of Engineering Technology, Hyderabad. Then this is data science using R programming, Blue Crest, Liberia. And this is Reva University. I acted as a international panel member and resource person. And this is Karpaga Vinayaga College of Engineering and Technology, acted as a resource person. The topic is COVID-19 virus detection using deep learning techniques. And this is a webinar on implementation of data science applications using machine learning algorithms at Vijnana Bharati Institute of Technology, Hyderabad. And this is research conclave I have conducted throughout the entire Liberia. About 49 universities research members I have invited. And I have clarified all the doubts for all the doctorates and research scholars. This is one more resource person, data science applications using ML and DL techniques, Krishna University at Vijayawada. Then this is Kale University. I have acted as a resource person. The topic name is robotic process automation using UiPath. Then this is recent trends in applications of mathematics in one more engineering college at Andhra Pradesh. This is your college, Annai College of Arts and Science. Only I kept a few. Okay. And the future workshop is data science application using machine learning and deep learning techniques at one more engineering college at Vijayawada. Next, one more workshop, cyber security applications using Python. July 31st. If you want, you can attend these programs. I'm going to share links and you can utilize. I'm going to show you practical sessions actually. This is only theory sessions. And thank you one and all for giving me this wonderful opportunity, for Balambiga Madam and the principal. And thanks, I would like to thanks to Annai College of Arts and Science, Tiruchirappalli. Thank you for giving me this golden opportunity. My dear faculty members and participants, now this is your